Inverse trig. It's where it begins. What we've done up until this point gets you ready. Get you ready to handle real trig. We're now moving into what you would need in a calculus class. We'll get you ready for physics with all the different ideas you need there. So the rest of chapter 1, we just have inverse trig, and this is a beast. It's large. There's a lot of concepts. Real subtle stuff goes on here. A lot of little rules. And then we'll have 1.8, which is just going to be our word problem. So we'll start putting it to use, so you can see how these inverses, like why we have them and why we use them. We got to solidify that and help you all out there just going to physics. Let's get some practice so you don't see that shit the first time in physics. Let's jump into it. Now, I'm not going to give the full definition yet. I'm just going to give a piece. And if you know the full definition of what an inverse means, dope. That's freaking awesome. I'm stoked for you. Maybe you jump across a little bit at this point. But we're just going to think of it this way, just an inverse. Like I wrote it down as a function. We want to find its inverse. And there's a lot of rules to inverses and such, but let's just do this. Inverse. Let's just think this. Just go, all we do, we swap the x's and y's. Cool. You swap your inputs with your outputs. You swap your inputs with your outputs. It's a different thing. Your x's and your y's. So whatever your x value is becomes your y value. Whatever your y value was becomes your x value. So for an example, like we take a point here. And we go, hey, that point is that our x value is pi over 2. And our y value is 1. Well, the inverse of that would be 1 comma pi over 2. That would be the inverse. So, I don't know. Wherever the hell that thing would be. I think it would be like right in here or something. I don't know. I can't tell with my graph. But you're just going to swap the x's and the y's. So just go this far in the journey with me for right now. Because that's basically what we're going to do. We're going to swap out our angles for the ratios. It's just going to be backwards. So if you can solve a trig function one way, we'll be able to solve it the other way. So again, we're just swapping our inputs with our outputs. Now, unfortunately, we don't have the proper symmetry for this to be able to graph it super easy. Because it's not just like you turn it around, like you just take it and shift it 90 degrees. That's not going to work. So let me show you what the drawing would look like if we swapped all our x's and y's. I made something down below. And there it is. That's what I found. Think there's anything wrong with this graph here? So, because back up here we had notice our y values were from -1 to 1, so now our x values are from -1 to 1. We just swapped those things out. Everything was trapped. And then I put all these little values. They just pop right up. Cool. So I swapped it out. What the hell is wrong with this? We need to make a function. I'm trying to make some sort of function. I don't know, like g of x is equal to sine inverse of x. Or maybe it's written as arc sine. Two different ways of writing the same thing. Arc sine of x or sine inverse of x. That's the same thing. And that's what we're aiming for right here. We want to go get this inverse. We want to see what the graph looks like. Don't worry, you don't have to do any graphing, but we need to know what's up. So two different ways of writing that. I'm going to take the arc sine out. I traditionally write this way, but you will be asked in your text. Your text will bring it back and forth, so please make note of that. If it's a function, what does it have to pass? What's that rule? And that's right. Oh, shoot. The vertical line test. Oh, it fails. It can only hit, right? You draw a vertical line, it can only hit once. Because you can't have two different outputs for the same input. It doesn't make any sense for a function, like your paycheck. You work 40 hours, your boss can't just be like, nah, I'll give you this much or this much. I mean, unless you're working under the table, then you're screwed. But, right? You have one function, your paycheck, however many bucks an hour you get, times however many dollars you get, or how many hours you spend working. Vertical line test. So what we would actually need to do is we need to remove part of this. So somebody, now there's nothing here other than somebody said so back in the day, all right? So there's nothing to understand here other than somebody back in ancient Greece or something came up with this and went, all right, we're only going to keep part of it. We're going to get rid of anything above pi over 2. And we're going to get rid of anything below negative pi over 2. We're going to get rid of that. So we're just going to be left with a little piece. Because now what this does is it travels through all of our x values, right? From negative 1 to 1. Oh, but that used to be our y values because we're just swapping our x's with our y's. That's all we're doing. We're swapping x's and y's. And it travels only, our y values only go from negative pi over 2 up to positive pi over 2. Okay. So here's the big piece. We have our domain. Domain for this function. Domain has to do with x values. So the domain of sine inverse is negative 1 to 1. And its range, the y values that you can have, are going to be from negative pi over 2 to pi over 2. These used to be the x values, right? Those used to be our x values of y equals sine of x, right? If we were to write it in that way, not the inverse, but the other way. So we swapped our inputs with our outputs. These are now saying that the only angles you can have for an inverse are going to be between negative pi over 2 and pi over 2. Okay, well, I want to just go back up. I want to go back up and talk about this. We said, all right, there's this inverse function. There's this inverse function, we'll call it something else, sine inverse of x. So we wanted to mess with, now what happened was we restricted ourselves in between just this and this. That was that graph down below to create that inverse. We restricted ourselves in between negative pi over 2 and pi over 2 in our y values down here. But they used to be x values of our original function. So we're only going to be between negative pi over 2 and pi over 2 for our y values, and we already know that the heights, it can't be between anything bigger than 1 or smaller than negative 1. Let me jump inside of here real quick. Remember the unit circle? Just the unit circle part? From here to here, that's quadrant 1. From here to here, that's quadrant 2. From here to here, that's quadrant 3. From here to here, that's quadrant 4. And then it repeats upon itself. You're back to quad 1, you're back to quad 2. If we go back this way, let's count backwards. 4, 3, 2, 1, 4. 3, 2, and you can keep going. But we don't really give a shit about all this extra stuff at the end. All of this back here, we don't care about that. That's not what we're talking about. We want this. Just the stuff that's trapped between between negative pi over 2 and pi over 2. That's only quadrant 1 and quadrant 4. This is probably too much too soon, but I'll give you just the idea that now our y values have to be between negative pi over 2 and pi over 2, which means this inverse sine of x, its answers are always between negative pi over 2 and pi over 2. It can never pop out an answer bigger than pi over 2. It can never pop out an answer that's smaller than negative pi over 2. Look, it never has an answer larger than pi over 2. So it never is in the second quadrant or the third quadrant. But it's never smaller than negative pi over 2. So it can be in the fourth quadrant, but you have to write it as a negative angle. No like 11 pi's over 6. You'd have to say negative pi over 6. The same is going to work. It's the exact same thing for inverse cosine. The graph looks a little bit different. Actually, oh shit, I lied. It's not the exact same thing. Only the domain will be the same. And the next one we're going to mess around with tangent inverse, and then it'll just kind of give you cosine inverse. Hope you were able to gain anything from this. I'll catch you in the next one. This is tough, so give yourself a break as you go through. Maybe your teacher just sucks at explaining it.